Okay, so in this example, we know that the cosine of negative x is equal to 1/2, and that's a cofunction identity. So if we go ahead and make our hexagon to organize the trig identities, and in the center we always put a 1, then the leftmost vertex gets tangent, and we use our quotient identity to go around, so tangent is equal to sine divided by cosine. Then the reciprocal identities, so cosine's reciprocal is secant, sine's reciprocal is cosecant, tangent's reciprocal is cotangent. Okay, then the even odd identities, since this is cosine of negative angle, remember to find even identities, you look for the abbreviation that has an E, and that would be secant. So secant is an even function, and then its reciprocal would also be even, and all the others are odd. And even functions, we learned at the beginning of the year that when you have f of negative x, that's equal to f of x whenever your function is even. So if we apply that to the cosine of negative x, that means cosine of x is equal to the same thing, which is 1/2. So the cosine is 1/2. Then its reciprocal is secant, so the reciprocal of 1/2 is 2. That makes the secant equal to 2. And in our earlier examples, we did the Pythagorean identity, sine squared plus cosine squared is 1. We also did 1 plus cotangent squared is cosecant squared. So this time, let's try our third Pythagorean identity in the hexagon, which is tangent squared plus 1 is equal to secant squared from that triangle. So tangent squared x plus 1 equals secant squared x. And we'll substitute in what we know for secant, which is 2. So tangent squared x plus 1 is equal to 2 squared. And tangent squared x then is equal to 2 squared, which is 4, minus 1, which is 3. We'll square root both sides, and the tangent of x is plus or minus square root of 3. To decide which to keep, we look up at what we started with. Tangent of x is positive. It says tan x is greater than 0, so we're going to keep the positive square root of 3. And we can go ahead and add that to the hexagon. So tangent is positive square root of 3. Then to get the cotangent, that's the reciprocal, we'll go ahead and figure out what its reciprocal is. So reciprocal of root 3 is 1 over root 3. We'll rationalize that denominator, and we get square root of 3 over 3 for the cotangent. Okay, then to get the sine, we could use a quotient identity. Sine is tangent divided by secant. So sine of x equals tangent of x divided by secant of x. Tangent is square root of 3, secant is 2, and so the sine is the square root of 3 over 2. Okay, we could use the product identity here to find the cosecant. So if we use the left and right vertice for the product identity, we know that the cosecant of x is equal to the cotangent of x times the secant of x. And cotangent is the square root of 3 over 3. Secant is 2. And that leaves us with a 2 square root of 3 over 3. So cosecant is 2 square root of 3 over 3, and we found all 6 of the trig functions.